Physical characteristics and external anatomy of catfish. The armor plates are evident in Corydoras semiaquilus. Most catfish are bottom feeders. In general, they are negatively buoyant, which means that they will usually sink rather than float due to a reduced gas bladder and a heavy, bony head. Catfish have a variety of body shapes, though most have a cylindrical body with a flattened ventrum to allow for benthic feeding. A flattened head allows for digging through the substrate as well as perhaps serving as a hydrofoil. Some have a mouth that can expand to a large size and contains no incisiform teeth. Catfish generally feed through suction or gulping rather than biting and cutting prey. However, some families, notably Loricariidae and Astroblepidae, have a suckermouth that allows them to fasten themselves to objects in fast-moving water. Catfish also have a maxilla reduced to a support for barbels. This means that they are unable to protrude their mouths as other fish such as carp. Catfish may have up to 4 pairs of barbels, nasal, maxillary on each side of mouth, and 2 pairs of chin barbels, though pairs of barbels may be absent depending on the species. Catfish barbels always come as pairs. Many larger catfish also have chemoreceptors across their entire bodies, which means they taste anything they touch and smell any chemicals in the water. In catfish, gustation plays a primary role in the orientation and location of food. Because their barbels and chemoreception are more important in detecting food. The eyes on catfish are generally small. Like other ostariophycens, they are characterized by the presence of a Weberian apparatus. Their well-developed Weberian apparatus and reduced gas bladder allow for improved hearing as well as sound production. The most staggering health benefits of catfish. A cat and a fish combined. Can it be? This is catfish, found abundantly throughout the planet and oozing with health benefits. Health benefits of catfish, scientifically known as the Siluriformes. Catfish are a diverse group of over 3,000 ray-finned fish found everywhere except Antarctica. They thrive in freshwater ecosystems like streams and rivers, although some have adapted to live in caves and salt water. Catfish are actually one of the most farmed fish, primarily due to their popularity and high consumption levels. In fact, some types of catfish, such as the Mekong catfish, are now endangered due to water pollution and overfishing. They are called catfish, as they obviously don't look like cats. However, they do have a strong set of whiskers, which sets them apart from most other fish types. Catfish also have no scales, and the mucus on their skin is used in cutaneous respiration, wherein the fish breathes through its skin. Some types of catfish have bony platelets called scutes to protect their skin, while others have a sort of body armor to protect themselves. The catfish mainly live in freshwater, but saltwater types also exist. Their taste is mild, and they are low in fat. Their skin is also edible, but it must be removed before cooking. Health benefits of catfish helps form bones and teeth. The phosphorus content of catfish is essential for the overall health, as the mineral plays an important role in the formation of bones and teeth. Helps boost cognition. Research shows that those who eat seafood are less likely to suffer from dementia and other memory conditions. The nutrients in catfish also help boost brain power. Aids in digestive health. Studies suggest that a diet rich in fish oil helps protect the body against serious bowel conditions. Moreover, there are some studies that suggest omega-3 fatty acids may help slow down the progress of inflammatory bowel conditions. Beneficial for the nervous system, the vitamin B12 in the catfish may help maintain the health of the nervous system. This is one of the best health benefits of catfish. Helps fight depression. That catfish may help reduce the risk of depression. Aids in losing weight. Catfish is beneficial in losing weight because it has carbohydrates and but a small fat content. Furthermore, it is oozing in protein, making it a good source of energy. Good for the heart. The omega-3 fatty acids in catfish are beneficial in lowering the risk of heart illnesses. Catfish or catfishes, order Siluriformes, or Nematognathi, are a diverse group of ray-finned fish, named for their prominent barbels, which resemble a cat's whiskers. Catfish range in size and behavior from the three largest species alive, the Mekong giant catfish from Southeast Asia, the Wells catfish of Eurasia, and the Paraiba of South America, to detritivore species that eat dead material on the bottom, and even to a tiny parasitic species commonly called the Candiru, Vandellia serosa. Neither the armor-plated types nor the naked types have scales. Despite their name, not all catfish have prominent barbels or whiskers. Members of the Siluriformes order are defined by features of the skull and swim bladder. Catfish are of considerable commercial importance. Many of the larger species are farmed or fished for food. Many of the smaller species, particularly the genus Corydoras, are important in the aquarium hobby. Many catfish are nocturnal, but others, many Echinopteridae, are crepuscular or diurnal. Most Loricariidae or Cylindrical. Catfish is not just a delicious fish, it also has astounding health benefits. Extant catfish species live inland or in coastal waters of every continent except Antarctica. Catfish have inhabited all continents at one time or another. They are most diverse in tropical South America, Asia, and Africa, with one family native to North America and one family in Europe. More than half of all catfish species live in the Americas. They are the only ostariophycens that have entered freshwater habitats in Madagascar, Australia, and New Guinea. They are found in freshwater environments, though most inhabit shallow, running water. Representatives of at least 8 families are hypogene. Live underground with 3 families that are also troglobitic, inhabiting caves. One such species is Freedobaia cisternarum, known to live underground in phreatic habitats. Numerous species from the families Ariidae and Plotosidae, and a few species from among the Aspidinidae and Bagridae, are found in salt water. In the southern United States, catfish species may be known by a variety of slang names, such as mudcat, pollywogs, or chuckleheads. These nicknames are not standardized, so one area may call a bullhead catfish by the nickname chucklehead, while in another state or region, that nickname refers to the blue catfish. Walking catfish is an invasive species in Florida. Representatives of the genus Ictalurus have been introduced into European waters in the hope of obtaining a sporting and food resource. The European stock of American catfishes has not achieved the dimensions of these fish in their native waters, and have only increased the ecological pressure on native European fauna. Walking catfish have also been introduced in the fresh waters of Florida, with the voracious catfish becoming a major alien pest there. Flathead catfish, Pilotictis olivaris, is also a North American pest on Atlantic slope drainages. Pterygoplectus species, released by aquarium fish keepers, have also established feral populations in many warm waters around the world. Catfish do not have scales, their bodies are often naked. In some species, the mucus-covered skin is used in cutaneous respiration, where the fish breathes through its skin. In some catfish, the skin is covered in bony plates called scutes. Some form of body armor appears in various ways within the order. In Loricariidae and in the Asian genus Cicer, the armor is primarily made up of one or more rows of free dermal plates. Similar plates are found in large specimens of Lithodoras. These plates may be supported by vertebral processes, as in Scaloplacids and in Cicer, but the processes never fuse to the plates or form any external armor. By contrast, in the subfamily Daumatini family Amphiliidae and in Hoplomyzantines Aspidinidae, the armor is formed solely by expanded vertebral processes that form plates. Finally, the lateral armor of Doradids, Cicer, and Hoplomyzantines consists of hypertrophied lateral line ossicles with dorsal and ventral lamina. The channel catfish has 4 pairs of barbels. Mall catfish, other than members of Malapterouridae electric catfish, possess a strong, hollow, bony leading spine-like ray on their dorsal and pectoral fins. As a defense, these spines may be locked into place so that they stick outwards, which can inflict severe wounds. In numerous catfish species, these fin rays can be used to deliver a stinging protein if the fish is irritated. As many as half of all catfish species may be venomous in this fashion. making the Siluriformes overwhelmingly the vertebrate order with the largest number of venomous species. This venom is produced by glandular cells in the epidermal tissue covering the spines. In members of the family Plotosidae and of the genus Heteropneustes, this protein is so strong it may hospitalize humans who receive a sting. In Plotosis lineatus, the stings can be lethal. Juvenile catfish, like most fish, have relatively large heads, eyes, and posterior median fins in comparison to larger, more mature individuals. These juveniles can be readily placed in their families, particularly those with highly derived fin or body shapes. In some cases identification of the genus is possible. As far as known for most catfish, features that are often characteristic of species such as mouth and fin positions, fin shapes, and barbel lengths show little difference between juveniles and adults. For many species, pigmentation pattern is also similar in juveniles and adults. Thus, juvenile catfish generally resemble and develop smoothly into their adult form without distinct juvenile specializations. Exceptions to this are the aridid catfish, where the young retain yolk sacs late into juvenile stages, and many pomelidids, which may have elongated barbels and fin filaments or coloration patterns. Sexual dimorphism is reported in about half of all families of catfish. The modification of the anal fin into an intromittent organ. In internal fertilizers as well as accessory structures of the reproductive apparatus in both internal and external fertilizers have been described in species belonging to 11 different families. Giant Bogaryus yareli gunk caught in India. Some gunk in the Kali River grow large enough to attack humans and water buffalo. Catfish have one of the greatest ranges in size within a single order of bony fish. Many catfish have a maximum length of under 12 centimeters. Some of the smallest species of Aspridinidae and Trichomictridae reach sexual maturity at only 1 centimeter or 0.39 inches. The Wells catfish, Silurus glanis, and the much smaller related Aristotle's catfish are the only catfish indigenous to Europe, the former ranging throughout Europe, and the latter restricted to Greece. Mythology and literature record Wells catfish of astounding proportions, yet to be proven scientifically. The average size of the species is about 1.2 to 1.6 meter or 3.9 to 5.2 feet. And fish more than 2 meters or 6.6 feet are rare. However, they are known to exceed 2.5 meters or 8.2 feet in length and 100 kilograms or 220 libra in weight. A catfish weighing 88 kilograms or 194 libra was caught in the river Ebro, Spain. In North America, the largest Ictalurus furcatus or blue catfish caught in the Missouri River weighed 59 kilograms 130 libra. The largest flathead catfish, Pilotictis olivaris, ever caught was in Independence, Kansas, weighing 56 kilograms or 123 libra. These records pale in comparison to a giant Mekong catfish caught in northern Thailand and reported to the press almost 2 months later that weighed 293 kilograms or 646 libra. This is the largest giant Mekong catfish caught since Thai officials started keeping records in 1981. Also in Asia, a man caught a 75.5 kilograms or 166.4 libra gunk following 3 fatal attacks on humans in the Kali River on the India-Nepal border. Wade was of the opinion that the offending fish must have been significantly larger than this to have taken an 18-year-old boy as well as a water buffalo. Parabobrachyplatystoma filamentosum can grow exceptionally large and are native to the Amazon basin. They can occasionally grow to 200 kilograms or 440 libras, as evidenced by numerous catches. There are also reports in the region of deaths from being swallowed by these fish. Cryptopterus vitriolus glass catfish have transparent bodies lacking both scales and pigments. Most of the internal organs are located near the head. In many catfish, the humeral process is a bony process extending backward from the pectoral girdle immediately above the base of the pectoral fin. It lies beneath the skin where its outline may be determined by dissecting the skin or probing with a needle. The retina of catfish are composed of single cones and large rods. Many catfish have a tapetum lucidum which may help enhance photon capture and increase low light sensitivity. Double cones, though present in most teleosts, are absent from catfish. The anatomical organization of the testis in catfish is variable among the families of catfish, but the majority of them present fringed testis Ictaluridae, Claridae, Echinopteridae, Doradidae, Pomelidae, and Pseudopomelidae. In the testes of some species of Siluriformes, organs and structures such as a spermatogenic cranial region and a secretory caudal region are observed, in addition to the presence of seminal vesicles in the caudal region. The total number of fringes and their length are different in the caudal and cranial portions between species. Fringes of the caudal region may present tubules, in which the lumen is filled by secretion and spermatozoa. Spermatocysts are formed from cytoplasmic extensions of Sertoli cells. The release of spermatozoa is allowed by breaking of the cyst walls. The occurrence of seminal vesicles, in spite of their interspecific variability in size, gross morphology, and function, has not been related to the mode of fertilization. They are typically paired, multi-chambered, and connected with the sperm duct, and have been reported to play a glandular and a storage function. Seminal vesicle secretion may include steroids and steroid glucuronides, with hormonal and pheromonal functions, but it appears to be primarily constituted of mucoproteins, acid mucopolysaccharides, and phospholipids. Fish ovaries may be of two types, gymovarian or cystovarian. In the first type, the oocytes are released directly into the chylomyic cavity and then eliminated. In the second type, the oocytes are conveyed to the exterior through the oviduct. Many catfish are cystovarian in type, including Pseudoplatystoma coruscans, P. fasciatum, Lophiocilurus alexandri, and Loricaria lentiginosa. Catfish can produce different types of sounds and also have well-developed auditory reception used to discriminate between sounds with different pitches and velocities. They are also able to determine the distance of the sound's origin and from what direction it originated. This is a very important fish communication mechanism, especially during agonistic and distress behaviors. Catfish are able to produce a variety of sounds for communication that can be classified into two groups: drumming sounds and stridulation sounds. The variability in catfish sound signals differs due to a few factors: the mechanism by which the sound is produced, the function of the resulting sound, and physiological differences such as size, sex, and age. To create a drumming sound, catfish use an indirect vibration mechanism using a swim bladder. In these fishes, sonic muscles insert on the ramus mulleri, also known as the elastic spring. The sonic muscles pull the elastic spring forward and extend the swim bladder. When the muscles relax, the tension in the spring quickly returns the swim bladder to its original position, which produces the sound. Catfish also have a sound-generating mechanism in their pectoral fins. Many species in the catfish family possess an enhanced first pectoral fin ray, called the spine, which can be moved by large abductor and adductor muscles. The base of the catfish's spines has a sequence of ridges, and the spine normally slides within a groove on the fish's pelvic girdle during routine movement. But, pressing the ridges on the spine against the pelvic girdle groove creates a series of short pulses. The movement is analogous to a finger moving down the teeth of a comb, and consequently a series of sharp taps is produced. Sound-generating mechanisms are often different between genders. In some catfish, pectoral fins are longer in males than in females of similar length. And differences in the characteristic of the sounds produced were also observed. Comparison between families of the same order of catfish demonstrated family and species-specific patterns of vocalization, according to a study by Maria Clara Amorim. During courtship behavior in 3 species of Corydoras catfish, all males actively produced stridulation sounds before egg fertilization, and the species songs were different in pulse number and sound duration. Sound production in catfish may also be correlated with fighting and alarm calls. According to a study by Kotz, sounds for disturbance, e.g. alarm, and agonistic behavior were not significantly different, which suggests distress sounds can be used to sample variation in agonistic sound production. However, in a comparison of a few different species of tropical catfish, some fish put under distress conditions produced a higher intensity of stridulatory sounds than drumming sounds. Differences in the proportion of drumming versus stridulation sounds depend on morphological constraints, such as different sizes of drumming muscles and pectoral spines. Due to these constraints, some fish may not even be able to produce a specific sound. In several different species of catfish, aggressive sound production occurs during cover side defense or during threats from other fish. More specifically, in long-whiskered catfish, drumming sounds are used as a threatening signal and stridulations are used as a defense signal. Kotz investigated 83 species from 14 families of catfish, and determined that catfish produce more stridulatory sounds in disturbance situations and more swim bladder sounds in intraspecific conflicts.